rational functions. We're going to start graphing rational functions. And again, what will probably happen in this chapter with these rational functions will probably be calculator, non-calculator again. Yeah, I had a graph paper here. I left it on your desk. If you guys want to grab a couple of sheets and just pass them around. I know, I don't like to count. I just grab chunks of paper. It's easier to get chunks of paper. It's easier that way.
Will we need some for...
What's that? I don't know. Yeah, take one. Make sure all you really need is 2 sheets, one for your notes and one for homework. So we're going to graph these graph paper today. But here's what we've got. Rational functions, or any function, can be written in the form p of x divided by q of x, where p and q are polynomials. So basically, we're dividing polynomials out, and we're going to be graphing them. Now, excuse me. We've done this a little bit here and there. You guys have graphed some of these similar ideas in the past. You guys have all probably seen the graph of y equals 1 over x. You probably have all seen that. Okay? When you're dealing with this simple function, what's that? No, go say it. What were you saying? No, what did you say? Well, I didn't hear you. How do you know?
It was definitely wrong.
Okay. Now, do you guys remember a little something called an asymptote?
No.
No. You don't know what an asymptote is? You don't know an asymptote from the hole in the ground? You ever heard that one? Oh, math humor. Not good. What can x be?
0.
0. So what happens here is there's what we call an asymptote, A-S-M-Y asymptote.
I like that spelling.
Asymptote. Yeah, it's not asymptote.
I just. Oh.
I don't know. Asymptote. I can't spell that. You want me to look it up? We should probably Google that.
Google it.
I found it written somewhere.
What is it?
It's right here.
Asymptotes.
I was right. I had the Y wrong.
Yeah, you switched it.
Asymptotes.
Okay. Asymptote.
Potassium code.
All right. Anyway, so what happens here is you get what's called an asymptote. An asymptote is a value that you are approaching. It is a
Mr. Asymptote.
It is a value that it cannot have in your denominator. Okay. Within these things, you're going to have asymptotes, whether or not they're vertical. Vertical asymptotes are always going to be at the zeros of denominators. Okay. A vertical asymptote in this case here, the 0 of the denominator is 0 because I can't have 0 in the denominator here. Okay.
With the asymptote is where
It's on the x-axis, or excuse me, it's on the y-axis where x equals 0. In this case, it's at x equals 0. All right. If you think about it another way, if you want to look at if it was 1 over x minus 2, what would my asymptote be? 2 at 2 and x equals 2. It's the 0 of the denominator. Where can't x be equal to? So this is what you're looking for. So when we start these things out, we're looking for these asymptotes. Yeah. And now, when you think again to how you started to graph a lot of these things, you used to start these things by making tables. Now, I've split this basically into two, what we call half planes. One side of the asymptote, the other side of the asymptote. If I just pick some easy numbers at 1, what's y? 1. At 2, what's y? 1/2. And then it goes 1/3, and so on. If y was, or excuse me, if x was 1/2, what would y be? 2. Very good. If x is at 1/2, y is at 2. So it goes like this. So what's happening is you get this curve. Okay. What's going on here is your curve is getting closer and closer and closer and closer towards that asymptote, but yet it will never touch it.
So what exactly is the asymptote?
Asymptote? It's a value that you're approaching that you're never going to get to. It's like I can get infinitely closer and closer and closer and closer to the wall without touching it in theory. You can always cut a number in half without it running out, without turning it into 0. You can always find a number closer to 0. You can always get closer and closer and closer. Yes? Sure. I'll agree. You're probably right. Okay? Now, if you think about it going the other direction, if x is -1, at half, it's at 2, and you basically get the same thing going the other direction. So what we're going to wind up doing here, guys, when we start looking at these simple functions like this, is that we're going to find asymptotes and then plot a couple of points on either side. We're going to have curves. We're going to have a curve here. You're dying. You okay?
He's his own function.
You all right today?
No, he's never right.
Well, I know he's never really right. Is asymptote that funny?
No, it's really stupid.
Say it.
Should I pause it? Is it PG?
He wants to name his child Twombly.
Oh, anywho. In this graph, hey guys, in this graph, you will also have noticed that no matter what, we can get infinitely closer and closer to 0 going the other direction as well. As x becomes larger and larger and larger, y is getting smaller and smaller and smaller, but yet it won't reach 0. As x gets smaller and smaller and smaller, y is getting bigger and bigger and bigger, okay? As we're dealing with positive values. The moment it becomes negative, the things shift around. So what we're going to wind up with here today are working with AH's and K again, not only just with 1 over x. We're going to shift everything and move stuff around and to be able to identify our new asymptotes. So each one of these style graphs always starts out going to be the same. Where we have the function y equals a over x minus h plus k. You're going to have vertical and horizontal asymptotes at these different values. We're going to have vertical asymptotes at x equals h, and horizontal asymptotes at excuse me, y equals k. These branches of the hyperbola, remember, they're going to be on either side of one another. They're going to have these curves here. So when we start these types of problems out, the easiest thing to do is to always label out what your A, H, and K are. Just like we did every time we ever have A, H, and K. A value here is -2. H is -3. And K is -1. Is everybody okay with that? by just labeling out that A, H, and K then, I can go ahead and sketch my asymptotes. By sketching out my asymptotes here. So we get a piece of graph paper out. Again, I start by sketching out my vertical asymptote. My vertical asymptote is at x equals -3. My horizontal asymptote's at y equals -1. And what we've done here, ladies and gentlemen, is just kind of shifted around. Instead of being bounded around the origin, we've moved that to a new intersection spot. Okay. So now I have vertical asymptote, horizontal asymptote. The easiest way to plot these now is just to pick a couple of points. Is the glare that bad, Anna? What we're going to do here is we're going to pick a couple of Is that better? If I do it like that? You guys okay with that then? All we have to do is pick a couple of points on either side of those asymptotes and plot them. They're going to have curves here. So if I pick out easy values to work with, let's say if I use -5. Why do you think I want to choose to use -5 in this problem?
Because it's a -2 on top.
Yeah, because it works out nice and clean as far as the fraction is concerned. I'm just going to use values that make my life easy here. So if I pick -5, what's -5 plus 3?
-2.
What's -2 divided by -2?
2.
1. What's 1 minus 0? Or 1 minus 1?
0.
Thank you. So at -5, it's 0. There's 1 point. Okay. Can I use -4? I mean, it's not the greatest, but it still works, right? All right, what's -4 plus 3? What's -2 divided by -1? What's 2 minus 1? So at -4, it's at 1. So I know that now, from just those 2 points, I can tell that my curve is going to start looking like this. Yes, sir.
So will that asymptote never touch the
Bless you. The curve?
Yeah.
The curve will get infinitely closer and closer and closer to -3, but it'll never get there. Yeah. Yeah. And now I just do the same thing on the other side. Well, if I use -2, what's -2 plus 3? What's -2 divided by 1? -2 minus 1 is? So at -2 is at -3. So I go here. All right. Again, now I'm going to use -1. What's -1 plus 3? -2 divided by 2. -1 minus 1. And my curve is going this way. They're going to be mirror images of one another. Okay? So what we're looking at being able to do here, yeah,
If you know that you're very interested, why do you have other flips?
I was just getting there. Because what I'm going to ask you guys to be able to do is I want you to give me 2 sets of points on both curves. I want 2 ordered pairs on both curves. Okay?
So
Yeah.
can you take it from, you know, one, can you just figure it out from there? Like the next 2 points, or do you still want
So if you take a line of reflection, can you get the points of anyway?
You can, yes. If you can figure that through and you're right, that's fine. So my first one, yes, sir.
Wait, never mind.
That was an easy question. Thank you. Oh, was it -3, -3? Or no, excuse me, that was -2. Basically, that's what I want you to be able to do here, ladies and gentlemen. Be able to tell me what are two second order pairs on both curves. Okay? Again, the first thing that you want to be able to do is identify your horizontal and your vertical asymptotes. Once you plot those, you pick 2 points on both sides and go from there. All right? Can I go to another one? There's another style of these graphs as well, besides just the y equals a over x minus h. Sometimes they're written a little bit differently. Sometimes you have the form y equals a, oops. Sometimes you have that ax plus b. I'll write down the hints for this one. Sometimes they're written in the form like that. When they're written in the form like that, they're not following the same pattern as your horizontal and vertical asymptotes out of this. So what you have to understand is, again, the vertical asymptote is going to be the 0 of the denominator. That's going to be a standard for everything. Whatever your 0 for your denominator is, that's going to be your vertical asymptote. Your horizontal asymptote is always going to be at the equation y equals a over c. Now that a value and c value wind up being the coefficients in front of the x. All right? It'll be the coefficients of the values of x. And if I write this out in terms of an equation so you can visualize what this looks like, you'll probably pick up on it real quick. If I say it's y equals 2x minus 4, 2x minus 3 over 4x plus 5. And from here, I just want to go ahead and identify where my asymptotes are first. My 0 of the denominator, in order to solve for the 0 of the denominator, all I have to do is set 4x plus 5 equal to 0. And what do you get? Negative 5/4. So my asymptote would be at y equals negative 5/4. Oops, that's a bad 4. It's x, excuse me, I don't know why I wrote y. And then my horizontal asymptote are the coefficients. The horizontal asymptote, because my vertical is this, my horizontal would be y equals 2 over 4, otherwise known as 1/2. Okay? That's what that style graph is going to, that's that style equation, what that's going to look like. Yes, sir? Not that I know of. I don't think there is. I really don't think there is. But you'll be able to tell the difference between these two real easy. Because what's tacked on? K. And what's not in this numerator? X. Gotcha.
Yeah. When you're graphing it, does it matter which quadrant you choose or which two?
It'll force you into the right quadrant. You can't just pick a quadrant and graph it. Because it'll be wrong. Because what'll happen here is once you plot your asymptotes, then you pick points on either side of the vertical asymptote, and then it'll lead you to the correct wavefront quadrants. Okay. So let me show you an example of this, how we graphed it then. Let's take a look at this one. We're going to graph y equals x plus 1 all over 2x minus 4. Yeah. And we're going to go back and start talking about domain and ranges again here too. Again, is this written in like the form of AH and K or the other one? It's written like the other one. The reason you can tell the difference between the two very fast is that notice that there's an x in the numerator on this one, and there's no k tacked on after the fraction. So again, when I start this out, I know that my vertical asymptote is going to be at the 0 of my denominator. So my vertical asymptote is going to be at 2, x equals 2. Okay? My horizontal asymptote is going to be at the equation y equals what over what in this case? 1/2. Very good. It's going to be at 1/2. Okay. So from there, I have now plotted my asymptotes. I have to figure out what quadrants I'm going to wind up being in just by picking the two numbers on either side. The next number to the right, excuse me, the next number to the right is going to be at 3. So if I substitute in 3 for x, bless you, I have 3 plus 1 over 2 times 3 minus 4. Well, that's 4 over 2, otherwise known as 2. So I have one of them at 3, 2. So my first order pair is at 3, 2. I'll go to 4 here. So I have 4 plus 1 over 2 times 4 minus 4.
Is it fine if you do a different number?
Yeah, you can do whatever you want. Doesn't matter. Because I know some of these things are going to give you, sometimes you get some crummy looking fractions, but all in all, you're just listing them out. So here I get what, 5/3? 5/4. Never said math was my strong suit. So 5/4. I don't know, that sounded good. 5/4, that's what, 1 and change? So now I know the direction that this is heading. Doing that. I go to the other side at 1. So I get 2 over, it's negative 1. And then 0 should be really easy. What's that? Yeah, 2 over negative 2 is negative 1, right? Okay. And then at 0, I get 1 over negative 4. So we're doing this. And Noah had a good question earlier. He said, is it okay if I choose different any 2 points? Yeah. The only reason that I always choose the next 2 is sometimes it's just a quick representation. If you wanted to pick 6, 10, if you want to start messing with some of the fractions to get easier values sometimes, it's not a big deal to me. It's not a problem. All I'm asking you guys to do is label your asymptotes and give me a pair of points on both sides. Do you see how it forces you to the correct quadrant now? All right. Try this one, please. Thank you, sir. When I look at this one for the domain, my domain is going to be all the possible x values, except what? What can't x be? 3. So it's all but 3.
Isn't it 4?
Oh, I thought it was at 3 for some reason. All but 4.
3,
Yeah, so the x value can't be at that asymptote. It can't be at your vertical asymptote. Then your range is going to be everything except what?
3.
Your domain and range will be defined by the asymptotes. Okay? That's what we're looking at doing here today, guys. Not so scary? All right. Do you want to do another one, or we give you some? I just give you some props.